Hi guys, so this is from Module 16 and 17's study guide. Again, we're dealing with arc length, sector area, equations of circles, and even converting from degrees to radians, and then radians to degrees. So let's get into it. Basically, first things first, they're dealing with us finding the circumference and the area of each circle below for numbers 1 through 4. Give the exact answer and round using the answer or using 3.14 for pi. Okay, so first things first, let's deal with the circumference for number 1. The circumference formula again is C equals, your circumference should equal 2 pi r. Okay, that's 2 times pi times r. Now, what is r? They give it to us. Okay, so the radius is 12 meters. So pay attention to context. There is context. All right, so we have 2 pi r, which is really 2 pi times the 12 meters. Um, so pay close attention to that. It really just means 2 times 12 meters, which is 24 meters, and that is times pi still. And real quick, they're saying use 3.14 for pi, so that would be 24 times 3.14. And don't forget meters. So in your calculator real quick, and again, all of this can be done with your calculator. So you should get 24 times 3.14, and you should get, for your circumference, 75.36. And don't forget we're talking about meters. And there's your answer for circumference. Now, the next thing they ask you for is area. Again, area is pi r squared. Okay, again, same radius, which is 12, so you're going to have pi times 12 meters squared. And again, when you square meters, it's going to be meters squared, okay? So you're going to get 144 times pi square meters. Okay, now where did I get the 144? 12 squared is 12 times 12. All right, so that's 144. All right, and they also said to use 3.14 for pi, so just you could do a lot of this in your calculator. Probably already have the answer, right? So 144 times 3.14, and again, you should get 452.16 square meters. That's a big circle. Wow. And that again is for your area. All right, so again, same concept for number 2. That's on you. Okay, you do, I do, just like that. Now, number 3 is very similar to number 1 and 2, just no pretty picture. And instead of giving the diameter, the radius, they give you the diameter. Now, remember, the radius is half of the diameter. And if they said the diameter was 6, that's just, what's half of 6? 3. So in reality, they're telling you that the radius here is 3, and remember context, 3 inches. So apply the same process as in number 1. So circumference first, which is 2 pi r. R happens to be 3 inches. So you're going to get 6 pi inches. And again, they said use 3.14, so 6 times 3.14. And you should get 18.84 inches for your circumference. And then let's deal with area. Same formula, but your radius is 3 inches. So don't forget, when we're dealing with area, your increments will be squared. Okay, so you're going to have 9 pi square inches. Again, use 3.14 for pi, so 9 times 3.14. And you should get for your area 28.26 square inches. Sorry, that's a square up there. It's a terrible 2, I know. All right, number 4. That's on you. All right, same process as number 3. All right, number 5. Given the circumference and find the radius of each circle, use your calculator's value of, sorry, that's supposed to be pi. Okay. Round your answer to the nearest tenth. All right, so they give us the circumference and they say to find the radius of each circle, round to the nearest tenth. Okay, so that's something to note. All right, so remember circumference equals 2 pi r. Well, if they tell us that the circumference in this situation, right, which again is 2 pi r, is 4 pi, well, let's just solve for the r. Let's isolate the variable. So how do we get rid of multiplying 2 pi? You divide. Well, you do one side, do the other, and 2's gives you that 1, right? And you're going to have, let me draw an arrow. That's an arrow. You're going to have radius equals, what's 4 pi divided by 2? And you should just realize that's just 2. Now remember context, it's in inches, so your radius is 2 inches. Okay, so I think that's all they wanted there. Number 6, you do, I do, just like that. Now, yeah, so same concept as number 5. All right, number 7. So again, number 6 is for you. Number 7, find the area of each sector. Oh, good, sector area. Give the exact and round your answer using 3.14. Okay, for pi. All right, so we have, again, our sector area formula. We have a certain degree measure, well, out of 360 degrees for a full circle. Now, the area formula is pi r squared, but now we only care about whatever angle, central angle that we have that we care about, and that's the sector area. So in this situation, we only care about 45 degrees out of 360 degrees. And again, our radius is given right here. So this is our r, that's our radius, and this is our m, our measure, all right, our angle measure. So 45 divided by 360 times pi times 16 yards squared. All right, so you could do this entirely in your calculator if you want. You could do 16 squared, which is 256. Again, times pi. And don't forget, we just squared that 16 yards, so we're going to have square yards. All right, times the 45 over the 360. If you know your fractions, you would know that that is the same as saying, I believe it's 1 over 8. Let me see real quick. I'll double check. I think so. Yeah, 1 over 8. All right, so you can reduce if you want to do that. So you could just use your calculator, 45 divided by 360. You get 0.125 times the 256 and also times the 3.14. And you should get 100.48. Okay, and that's square yards. All right, so double check. Try it in the calculator. See if you can do it in the calculator. And yeah, see if you get that. All right. Sorry, that 8 should not be here. This is number 8. All right, so number 8, same concept. That's for you for homework. Okay. They want you to find this measure. Okay, so that's something to note, and they do give you the radius. So number 8 is on you, just like number 7. Okay, so I'll do number 9. Number 10 is over here, and that one is for you as well. But again, number 9, they're asking for sector area. Yeah, find the area of each sector. Okay, let me see real quick. Interesting. So I just realized out of this entire study guide, they don't they don't give you arc length. So we're not just going to find the area, we're also going to find the arc length. So I'm adding that into this study guide so we can make sure we went over it and you practice it. Okay, just in case it's also on the test. So going back to number 7, yeah, we found the area, but now we're going to find the arc length. Now remember, the arc length is whatever our measure is out of 360 times 2 pi r. Okay, that's related to circumference. And really what we're doing is we're just finding the length of this piece right here, that minor arc. So we only care about 45 degrees out of the whole circle, and our radius is 16 yards. Okay, so 16 yards. 2 times 6 is 32 times the pi. And again, 45 out of 360 is just the same as saying 1 over 8. Okay, if you reduce. And 32 divided by 8 is 4. So you have 4 pi and then times 3.14. And it looks like, and again, this is in terms of yards, it looks like your arc length is going to be 12.56 yards. Okay, so again, number 8, find the area and arc length. Okay, get your practice. Again, just use those formulas. Use that formula, make sure you remember it. Use this formula, make sure you remember it for your area, and you should be okay. So tell you what, I want to really make sure you guys are good on this. So number 9 is also for homework. Okay, so do number 8, 9, 10. Use the formulas correctly, learn how to use your calculator correctly, and make sure you do not forget about context. All right, use the information provided, write the equation for each circle. This center, again, that's my h value, that's my k value, and my radius is 2. Nice. So remember, the formula for a circle is x minus h squared plus y minus k squared, and that should equal your radius squared. Okay, so the negative h is just saying whatever your h is, in this case 1, it's going to be opposite. So if it's a positive 1, it's going to be negative 1. So we're going to have x minus 1 squared plus your y value, okay, whatever it is, it's 16. And remember the formula here is negative k, and that's basically just saying whatever the opposite is of your k value. So what's the opposite of positive 16? Negative 16. And then you square it. Our radius happens to be 2, but don't forget the formula says your radius is squared. So in the end, you're going to have x minus 1 squared plus y minus 16 squared, all equaling 4. Okay, so be aware of that. That is my equation for the circle. Number 12, that's on you. And I'll tell you what, I'll do number 13, all right, for you guys. So my h value is 0, my k value is negative 7, and my radius is 6. So I have x minus 0, which is really just x all by himself, right? Because 0, why bother, right? Now I'll tell you what, I'll just go ahead and write it so you kind of guys see it. All right, so again, x minus 0 squared plus, what's my k value? Negative 7. But again, what's the opposite of negative 7? Positive 7. Okay, and we square it. Our radius is 6. And we square it. So again, our formula is really just x squared plus y plus 7 squared, and then equals 36 because 6 times 6. So notice how the 0, it's like, oh, la-di-da. We can just leave it out. All right, number 14. That's on you. Same concept. Apply the formula correctly. Number 15, the origin is really just 0, comma 0. And I'll tell you what, I'll do that one. It's just going to be this, right? 0, comma 0. Why bother substituting the zeros, right? Now the diameter, again, that means the radius is 5. Okay. And what's 5 squared? 25. Done. Okay, and again, why is there no parentheses with the x and the y? Because this happened. All right, how that 0, kind of like who cares, right? From up here, it's the same concept just for both the x and the y because your h and k are both 0. All right, number 16, that's for you. Work on that. Number 17 and 18, identify the center and the radius of each, sketch the graph. Sweet. So let's find my center. And again, my center is at whatever the opposite is of my h value and whatever the opposite is of my k value. And then my radius is right over here, but don't forget it's really squared. So technically my radius right here is 2 because what's the square root of 4, right? And that should be 2. All right, so center is at, let's see, my h value is -1. What's the opposite of -1? +1. My k value, okay, is +2. What's the opposite of +2? -2. So my center is at 1, comma, -2. That's right here. My radius, again, is 2. So go 1, 2, 1, 2, 1, 2, 1, 2. And then that will kind of help guide my outer edge of my circle. And drawing a circle on a touchscreen is pretty difficult. But yeah, that's how you would sketch that graph. So tell you what, number 18, that's on you. Same concept as number 17. You do, I do, just like that. And then also remember opposite of h, opposite of k. And then what's the square root of the number that's to the right? And that'll give you the radius. All right, use the information provided to write the equation of each circle. And they are also saying find the area and the circumference of the circle. Did they do that for number 17, 18? No. Okay, just sketch. Okay. All right, so let's do this. Find your center. Looks like my center is at 1, comma, -1. And it looks like my radius, let me count, 1, 2, 3. Yep, looks like my radius is 3. So those are the two important things you need to know, your center and your radius. So that gives you your h value, your k value, and your r. So let's follow the formula. We have, again, x minus h squared plus y minus k squared equaling r squared. Okay, so what's the opposite of our h value, which is 1? It's -1 squared, and then plus whatever your y is, which is -1. But what's the opposite of your k? Or what's the opposite of -1? +1 squared. And then again, your radius is 3. Don't forget we're squaring it. So in the end, you're going to have x minus 1 squared plus y plus 1 squared. And 3 squared is really just 3 times 3, which is 9. And that is your equation of your circle. Now, again, they asked you to find the circumference. So that's just 2 pi r. Your r was 3. So really, you're just doing 2 pi, or 2 times pi times 3. 2 times 3 is 6. And that's 6 pi. You could do 3.14 if they said. If they didn't say it, you could do 6 times whatever your pi symbol is. I'm just going to do 3.14, and you should get 18.84. I really feel like I've gotten that answer somewhere. I think it was a Kahoot maybe that I set up recently. So we got circumference. Now remember, area is pi r squared, and we already said radius is 3, right? So we're just going to square that 3. I know, horrible 3, which is 9, and 9 times pi, 9 times 3.14, and you should have gotten for your area again, 28.26. All right, so yeah. All right, so number 20, that's on you. Same concept. Give me the equation. So first things first, find your center, find your h and k value, and then find your radius. Okay, again, finding the radius, start at the center, and then count all the way to your edges. That's how I was able to find my radius. All right, same concept for 21. So that's for you. Same concept for 22. That is for you. Get your practice in. All right, so lastly, convert each radian to measure into degrees. Again, your conversion ratio needs to be where you can factor or you can cancel out uh, your pi, or you could always do substitute in. If you remember, pi is 180, and you can always substitute that in. So you could always just substitute in 180 for pi. Oops, that's supposed to be a 3. My bad. Okay, which is 60. Now, if you use 60 degrees, if you use the conversion ratio, again, that's the conversion ratio that I have, 180 over pi. If you use that, nothing's wrong with that. It's perfectly fine. All right. The pi's cancel out, right? Because that's just 1. And then you get 180 over 3, which is the same thing that you'd get if you were to just substitute in for pi. All right. So you get 60 degrees there. All right. Number 6, that's for you. Number 7, that's for you. Number 8, that's for you. All right. Knock those out real quick. All right, so this is the one that a lot of kids have issues with. We are converting from degrees into radians. That means we're going from degrees to some number or fraction with pi, okay? Now, remember the conversion ratio that we used up here was 180 over pi. Well, now it's going to be flipped because we're going the other way with it. So it's going to be pi over 180. So when you do that, you're going to get 45 times the pi all over 180. Now the real question is, can I reduce? So this is really where you have to know your fractions. And I'm going to go ahead and say, you know what, I think 45 and 180 might have a factor of 5. So I'm going to go ahead and do that. One thing I also noticed is both are factorable by 9. So I'm going to change my mind real quick. And I'm going to reduce by a factor of 9. So basically what I'm doing is I'm doing that, okay? So you could always double check 180 divided by 9. Oh yeah, that's 20. So when I do that, I'm going to get 45 divided by 9, which is 5. 180 divided by 9, that's 20. Don't forget the pi is still on for the ride. I notice I can reduce even more by 5 again. So 5 divided by 5, that's 1. Don't forget the pi is up there in the numerator. And then 20 divided by 5 is 4. So know how you can reduce your fractions. Don't be afraid of fractions. All right. I think, yeah, you guys need practice on reducing fractions. So get your practice. Do it this way that I showed you with the whole reducing the fractions. Okay, get comfortable with that. Number 3, that's for homework. Number 4, that's on you. Okay, get your guys' practice. Okay, so that basically sums up everything you really need to know. If you have any questions, come see me. Feel free to ask. And again, please study and finish your homework and all that stuff. All right. Have a great day. Bye.